Hey, good morning. This is day 3 of our measurement unit. I'm going to get started, and remember, I'm not real good with technology, so I'm still learning how to use my writing device for the notes. So for this unit, what we'll be doing for measurement, first thing we'll be talking about is density. So which one of those do you think would feel heavier, like a rock that weighs a pound or a bunch of feathers that weighs a pound? Well, it would actually weigh the same, of course, but the volume would be different. The volume of a pound of feathers would be really, really huge, but a rock that weighs a pound isn't really all that heavy. So density kind of helps us make sense of some of that. Density is what compares the mass to the volume. Whatever the mass is per unit of volume. It's called an intensive physical property, and we'll talk about physical properties a little bit later. But an intensive physical property is a property of matter that doesn't change no matter how much you have. Density is the same no matter what. If I have a big, huge 7-pound bar of gold, the density of gold is going to be 19.3 grams per cubic centimeter. If I have a small gold earring, the density of that small gold earring would be the same. It would be 19.3 grams per cubic centimeter. Density is one of those properties that doesn't change no matter how much you have, so it's called an intensive physical property. The units for density can be grams per milliliter if it's a liquid volume, or grams per cubic centimeter if it's something like, say, a tissue box that has a very definite measurable length, width, and height. So if substances don't mix, the least dense substance would float on top. So here we have a density column that's on the slide to the right, and we've given you densities of 4 different liquids. So given those 4 densities, what do you think the density of substance A would be? Well, substance A would be whatever's on top, so that would be something that's the least dense. So which one of those is the least dense? Right, 0.69 grams per milliliter is the least dense. What's the density of substance D? Well, substance D is down there at the bottom of that graduated cylinder. That would be the most dense substance. So when you look back at all the densities, it looks like 1.26 grams per milliliter would be the greatest density. If an object had a density of 0.95 grams per milliliter and we dropped it into that graduated cylinder, where do you think it would end up? Well, let's see if I can get my pen working here. Let's see. There, if I get my pen working. So right there, ooh, everything got really small. Let's see if I can make that bigger for you. There we go. The density, let's see, 0.95. I'm way down here. 0.95. There we go. 0.95 would be, let's see, that would be, over here would be the 1.26. That would be 1.00. Next up would be 0.82. And we said the least dense would be 0.69. So 0.69. Okay, so where is that 0.95? Where does that fit in? Well, 0.95 would fit in somewhere right in here. Okay, it would float on top of the 1.00 density, whatever the substance is, and it would be in between the 0.82 and the 1.00 if we were to drop that object or mix that other liquid in there. So let's see, I'm going to erase my mess here and move on. See, look how technology, this is so cool. We didn't have this stuff when I was in school. We had overheads and we thought that was high tech. So let's see, go back to mouse mode. Okay. All right, so a block of wood measures 3.2 centimeters by 4.5 centimeters by 6.1 centimeters. When placed on a scale, it weighs 29 grams. So now we have to figure out what the density is. Well, what is 0.29? So let's get my pen going here again. 0.29 is what? What do you think that is? That is the mass. Let's see, mass equals, I promise I write better than this on the board, 29 grams. Okay, so if we were going to calculate density, we've got to remember density is equal to mass divided by volume. So we have the mass, so what we need now is the volume. Well, these 3 things are going to be our volume. One of the ways that we can calculate volume is length times width times height. So we're going to assume that's length times width times height. So in order to get the volume, I'm going to multiply those together. So I'm going to take out my calculator and we'll go 3.2 times 4.5 times 6.1 gives me 87.84. 87.84. Okay, so is this going to be milliliters or is this going to be grams per cubic centimeter? Right. Oh, sorry, my phone's on. It's going to be grams per cubic centimeter. So we go back here and we'll label it. We need to make sure we label these grams per cubic centimeter. So if density is mass divided by volume, I calculate my density, 29 divided by 87.84. And let's see what that is. 29 divided by 87.84 is 0.3301. And we said it's going to be grams per cubic centimeter. But I did 33.01 so that we can practice sig figs. So look back at your problem. We multiply, we use multiplication and division. When we do that, the sig fig rules are that you have to round your final answer to the weakest link, or whichever one of the numbers has the fewest sig figs. Well, I can only use numbers that are in my problem. Okay, so that has 2 sig figs, that has 2, that has 2, and that has 2. So my final answer gets rounded to 2 significant digits. So there's 1, there's 2, and that 0 is the only thing I'm allowed to look at. So the 0, does that round it up or leave it alone? Right, it leaves it alone. So the density here is 0.33 grams per cubic centimeter, and you would have gotten that question right. Okay, go next. Okay, this is a good question. If that block was cut in half, what would be the density of the 2 new blocks? Okay, so we've already figured out what the density of that block is. So if I cut it in half, and I take the density of each of those blocks, what's the density going to be for those 2 blocks? It's going to be the same. It's not going to be half. It's not going to be twice. It's going to be it's going to be the same. Because remember, density is an intensive property, so it doesn't matter how much I have. I've already found out what the density of that wood block is, so that means those 2 smaller blocks are going to have the same density because they will have less mass per unit of volume, but it'll be the same. It'll be the same as that big block. So it'll be the same. Okay, a marble weighs 45 grams. When it's placed in a graduated cylinder that has a volume of 29 milliliters of water in it, the water level raised to 44 milliliters. What is the density of the marble? Okay, let's go back here and we're going to move the pen again. So density is mass over volume. We've got the mass. There's my mass. Okay, but we have a couple of volumes, and it's some kind of object that we're taking the volume of. So what we're doing here is we're using something called water displacement. So it said that the volume was 29 milliliters in that graduated cylinder, and when I dropped the object in, the water level went up to 44 milliliters. So how do I find out what the volume of that object is? Well, it's the difference between the two. So 44 minus 29 will give me the volume of that object. 44 minus 29, that's going to be 15 milliliters. Okay, pretty easy. You guys have used water displacement before. Drop the object in, the water level goes higher. The difference between the 2 water levels is the volume of the object. So we now have a density and we got a volume right there. So density is 45 grams divided by 15 milliliters. So what is that? I can do that in my head. Right, it's 3. Let's look at sig figs. Okay, 45 has 2 sig figs, 29 has 2 sig figs, and 44 has 2 sig figs. So my final answer has to be rounded to 2 significant digits. Well, that number right there is only 1. So how do I make that 2? I do this. Because that 0, since it's a final 0 to the right of the decimal point, there's a dot there. There's that dot, the decimal. The 0 is behind the decimal point and it's on the end. It's a final 0. It's not in the middle or anything. It's at the end. So final zeros to the right of the decimal point are significant. So in order to make this thing 2 sig figs, I add a .0. And of course add my unit. you go. Pretty easy, right? Okay. Okay, next one. Oh, look, we've got pictures even. Graphics. It's beautiful. Okay, so there's my object. When I put the object in, it's taking a while to load. See, that water level gets higher. Okay. Oh, there we go. Now we're back at density. Okay. Rearrange the density formula to solve for mass and solve for volume. So let's see. Up here, I'll just put my density. Oh, back. Sorry. There we go. Well, shoot. I'm not having a lot of luck here, am I? Let's go back. All right, there we go. So now I can write on it. Okay, be patient with me, please. All right, so let's see. Here's my, let's see, density is, oh, do I have it? Oh, sorry. Is mass divided by volume. All right, so that's how you calculate density. Well, I want to rearrange and solve for mass first. So down here we get mass is equal to. So how do I do that? Well, a couple of ways to do it. I'll show you a cheater way to do it, actually. There we go. Draw a triangle. Some of your teachers hate this, but I figure if it's a tool, I'm going to let you use it. When you have a 3-variable formula like this, you can rearrange, you can put it in this triangle and it'll help you figure out how to rearrange the formula. So draw the triangle, separate it into 3 sections. Whatever's on the left goes on the left of the triangle. So what's on the left of this formula? D. So I put D right there. Whatever's on top goes on top up here. Well, what's on top? Right, mass. And the only other spot left is that one for volume. So the way I rearrange the formula is whatever it is that I'm looking for, I cover that up. So if I covered up mass, I would just have D next to V. So what is that? That's multiplying, right? So mass is density times volume. Okay, if I were going to solve for volume, same thing. I cover up my V. Cover up V, and what do? It's M over D. M divided by D. Mass divided by density. So that's how you rearrange it. That's a cheater way, but hey, you know what? It works. So let's go up here, and we're going to click on mouse again. There. Okay, percent error. That's the other thing we're going to learn today. We've got density. Now we're going to do percent error. Percent error is a pretty simple calculation. Those 2 bars on either side, that's an absolute value. So percent error is a useful tool when determining the precision of your calculations. Percent error is the theoretical value divided by, minus experimental value divided by the theoretical value. And then you'll multiply that by 100 because you want it to be a percent. So the theoretical value is a known value. It's an actual value. Let's say we're talking about gold again. The known density of gold is 19.3 grams per cubic centimeter. So that would be my theoretical value. My experimental value is my lab value. It's whatever I do at the lab table. The density of gold may be 19.3 grams per cubic centimeter, but when I measured it, I got 18.9 grams per cubic centimeter, which for a variety pack of reasons could happen at a lab. You know, you could mess something up, the balance could be not calibrated real well, that could happen. So anyway, so that's your experimental value, whatever you get at the lab table. Okay, so the density of lead, there we go, density of lead is 13.6 grams per cubic centimeter. The measured and calculated value was 12.9 grams per cubic centimeter. So what's the percent error? So let me click back on my pen here. Okay, so this is that my known value or my theoretical value or my experimental value? Well, it's known, so this is my theoretical value. That's supposed to be a T. T-H-E-O-R. Theoretical value. Okay, the measured and calculated value is 12.9, so 12.9 grams per cubic centimeter. Let's see, circle 12.9. That is my experimental value. Okay, remember the formula is going to be, let's see, I'm trying to get my pen right, percent error is equal to the theoretical value minus the experimental value divided by theoretical value. And remember, that has to be an absolute value, so when you get a negative, don't freak out. And then once you get that absolute value, you multiply by 100. Okay, we have the numbers that we need here. So my theoretical value, 13.6 minus 12.9. 12.9, there we go. Divided by what? The theoretical value again, 13.6. That's going to be absolute value. So let's see what that gives me. So 13.6 minus 12.9. That gives me 0.7, and I'm going to divide that by 13.6. Divided by 13.6. 0.05147. That's a lot of numbers. How many sig figs can I have? Right, I can have 3, because each of those numbers has 3, and we've been multiplying and dividing, which means you round to the weakest link, and both of them are 3 sig figs, so it doesn't really matter. So my answer is actually, it's a really long number, 05147 05882. Ha! It's a big number. So I can have 3 sig figs. Let's see. Oh, we can't do that yet. We're not done. That's not my final answer, is it? My final answer is after I do times 100. So times 100. So let's see what that gives me. So I know what it gives me. So it will give me 5. Oh, let's see. I don't want to do over there. 5.147058882. There we go. So it's 5 and some change is the answer. But let's get the correct number of sig figs. So I can have 3. So I've got 1, 2, 3. 7, does that round the 4 up to 5, or does it leave it at 4? Right. It rounds it up. So my final answer is 5.15%. So that's how you do percent error. The formula is not really that hard. You just have to remember that it is an absolute value, because sometimes you'll get a negative number and it's really no big deal. Multiply by 100 and you'll have that number in percent. And make sure you do your homework and ask us questions if you have them during the time that you're able to. You can either text them to us, or if we have a Zoom call open, feel free to do that also. So good luck. Let's see, let me turn this back to here, and have a good afternoon.